Sorry. So good morning to all. Okay, I think in that last lecture we have covered the topic that is the fit. May I right? Okay, fit topic we have covered in that last lecture. I think out of that, clearance fit and transition fit are completed, and only one fit is remaining. That is the transition clearance and interference fit we have covered, and what is meant by the transition fit, that point is only remaining. So may I right? Please correct me. Yes, anyone?
Yes, sir.
Okay, so just within 2-3 minutes I will revise the point so that it will better to understand. Okay, then what is meant by the fit? Okay, what is meant by the fit? Fit is nothing but it will indicate the tightness and the looseness between two mating parts. It is called as the fit. Okay, again that fit having the three types are there. First is the clearance fit, then second is the interference fit, and the third is the transition fit. May I right?
Transition.
Okay, then what is the simple definition of the clearance fit, or what is the simple hint how we can define that clearance fit? In that clearance fit, in that clearance fit, the shaft size is smaller. Okay, the shaft size is smaller. Sorry. Okay, shaft size is smaller and hole size is bigger, na?
Yes, sir.
Okay, means here the tolerance zone of shaft, the tolerance zone of hole, the tolerance zone of hole is bigger. Okay, the tolerance zone of hole is above to the tolerance zone of shaft. It is called as the clearance fit. Okay, so then what is meant by the interference fit? In that interference fit, the shaft size is greater and hole size is the smaller. And here how we can show the shaft? Yes, the tolerance zone of shaft should be, yes, please tell me, what is the condition for the interference fit? What is the condition? The tolerance zone of shaft, yes,
Above.
the tolerance zone of shaft, it should be above to the tolerance zone of hole. Okay, so this is the tolerance zone for the shaft and this is the tolerance zone for the hole. And what is the condition for the transition fit? Yes, then we can call it a transition fit. In that transition fit, you have to remember the transition fit, it will show the intermediate phase between clearance fit and interference fit. Means what? That transition, in that transition fit, the tolerance zone of hole, okay, just listen here, the tolerance zone of hole and the tolerance zone of shaft, both are overlapped. Okay, both are overlapped. If such condition is there, then we can call it is the transition fit. Okay, means like this. Suppose this is the tolerance zone for the hole. Suppose this is the tolerance zone for the hole, and again suppose this is the tolerance zone for the shaft. Okay, both the tolerance zone are overlapped to each other like this. Okay, if both the tolerance zones are overlapped to each other, then we can call it is the transition fit. Okay, so understood? Yes. What is the practical example here? Clearance fit. What is the practical example for the clearance fit? Just take the example of the piston and cylinder. Okay, whether you have seen the piston and cylinder, there is a small clearance is provided. See, this is the cylinder. Okay, see, this is the, you can call it the cylinder, and inside the cylinder we are knowing the piston is there. Okay, here the small clearance is provided. It is called as a clearance fit is there. Okay, then what is the example for the interference fit? Yes, what is the example of the interference fit? Yes, anyone? What is the example of the interference fit? Footstep bearing. Okay, footstep bearing. Okay, bearing and shaft, the arrangement of that. Or again, another example of the interference fit is the ceiling fan. Okay, whatever the ceiling fan you have seen in that your home, suppose this is the shaft of the ceiling fan, and here bearing is there. Okay, like this. Here bearing. This arrangement of the shaft and bearing. Here interference fit is there. And what is the example of the transition fit? Dual pin. Means suppose there is one hole is there, and inside that hole, suppose we have to just put the one pin. dual pin. It is called as a dual pin. Okay, these are the simple practical example of that fits are there. So understood? Yes. Yes.
Yes, sir.
Okay, so how to represent that fit? How to represent that fit in graphical manner? So just to see, there is one method, simple thing. Okay, whatever thing you have studied right now, according to that, just you have to show that fit in the graphical manner. Suppose this is the zero line. What is meant by the zero line? What is meant by the zero line?
Graphical representation of basic size.
Okay, means here, see, this is the zero line, means that zero line, it will show the basic size. Okay, we can write down here the basic size, it will show in the basic size. Right now, okay, right now, suppose, okay, on that, with the help of that zero line, we have to show the 3 fits. Okay, that 3 fits we have to show here. Okay, just you have to remember the definition, and according to that, just you have to write. Okay, suppose I'm going to show here the clearance fit. Okay, what is the condition for the clearance fit? That point we should know first of all. What is the condition for the clearance fit? What is the condition for the clearance fit? Here, the tolerance zone of hole, it should be upper side to the zero line, and the tolerance zone should be below to the, yes, this is the tolerance zone for the hole. This is the tolerance zone for the shaft. And then interference what? Yes, this is the tolerance zone for the shaft. This is the tolerance zone for the hole. And then transition fit, they are the overlap to each other like this. Okay, same condition I have to show with the help of that zero line. Okay, the zero line म्हणजे काय दर्शवणार आहे आपली basic size. It is correct. That zero line, it will show the basic size. For example, our basic size is the 50. Okay. Okay. Example just. Then how to show the clearance fit? How to show the clearance fit? Yes. Suppose this is the tolerance zone for the hole. It is correct. And suppose it is the tolerance zone for the shaft. Whether it is clearance fit? Yes. Whether it is clearance fit? Yes.
Yes, sir.
Just see now. So this is the tolerance zone. हा tolerance zone कुणाचा आहे? कुणाचा असेल हा tolerance zone? होलचा असेल.
Hole.
And see, this is the tolerance zone of the. This is the tolerance zone of the shaft. म्हणजे समजा for example is the upper limit. Sorry. See, this is the lower limit. This is the upper limit काहीतरी असेल. Again it is the upper limit, and again it is the lower limit. Okay. And see, this is the basic size. Okay. म्हणजे समजा हे किती असेल 51 असेल, 52 असेल, हे किती असेल 49 असेल, 48 असेल. मीन्स हियर तुमचा शाफ्ट छोटा आहे का मोठा आहे? शाफ्ट छोटा आहे का मोठा आहे?
Small.
Shaft is small, hole is bigger. Means that condition is satisfied for the clearance fit.
Yes, sir.
Yes. So it is called as the clearance fit. See, it is the clearance fit. Okay, in that similar manner, again we have to show the interference fit. Then how to show the interference fit? Tell me. How to show the interference fit? Yes. See, again we have to show here one tolerance zone on this side. Again, I will write down the tolerance zone on this side. Then tell me, what is the condition for the interference fit? What is the condition? See, this is the condition for the interference fit. Okay. Then tell me whether this is the tolerance zone for shaft or hole.
Shaft.
See here, this is the tolerance zone for the shaft. Okay. And this is the tolerance zone for the
Hole.
Okay. Just imagine same dimension. Suppose it is 51, it is 52. Again, it is upper limit, it is I think 49, and it is 48. Okay, see, this is the shaft. Okay, and this is the hole. Then from this dimension, you can easily understand here shaft is bigger, hole is smaller. Okay, means what is this? It is indicate the which bit? It is indicate the interference bit. Okay, so correct? Yes or no?
Yes, sir.
Okay. And then last transition bit. Then how to show the transition bit here? Okay, what is the condition for the transition bit? When the tolerance zone of hole and tolerance zone of the shaft both are overlapped. Okay, both are overlapped, then we can call it is the yes transition bit. Okay, then tell me how to draw it. How to draw? Suppose this is the tolerance zone for the shaft or hole, we can say. So this is the tolerance zone for the hole, and here we have to show the again we have to show the tolerance zone for the shaft. Again we can show here also, no problem, but again we can show here because here both the tolerance zones, see the tolerance zone of hole, tolerance zone of the shaft, both should be overlapped. See like this, both should be the overlap. This is for the hole, this is for the shaft. Okay, this is called as the yes transition bit. Okay, so understood how to show it in graphical manner.
Yes, sir.
Okay, so now that bit is completed. Now can I move over the next point? Yes.
Yes, sir.
Okay, our next point is again very important point, that is the hole basis system and the shaft basis system. Okay, the next point, very important point, very important topic is there. Okay, so again it is very important topic. Hole basis system. Okay, hole basis system and shaft basis system and shaft basis system. Hole basis system and the shaft basis system. So this is our new point. Okay, so first up on we will discuss here what is meant by the hole basis system, and then we will explain here the what is meant by the shaft basis system, and then we will differentiate it. Okay, so understood. So first up on I will take here hole basis system. What is meant by the hole basis system? A point. A. Okay, hole basis system. Hole basis system. Okay, so first up on I will write down here the definition. So you can also write down. Okay, the hole basis system is nothing but in this system. Okay, in this system, the size of hole. Okay, the size of hole is kept. It is important part. Is kept constant. Is kept constant. Okay. In hole basis system, you have to remember the size of hole. The size of hole, it should be kept as a constant, and 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 the shaft size, the shaft size is varied to achieve the different, to get or to achieve the different fits. It is called as the to achieve the different fits. It is called as the hole basis system. Okay, so understood what we have to do in that hole basis system. In that hole basis system, whatever size of hole is there. See, this is the, for example, this is the one hole is there. Okay, this is the hole is there, and in that hole basis system, the size of that hole, we have to keep a constant. Okay, the size of this hole we have to keep a constant, and the size of shaft, okay, the size of shaft we can vary to achieve the different fits. Okay, to achieve the different fits. Okay, so understood? Yes, the size of shaft we have to vary. The size of shaft we have to vary, but the size of shaft we have to keep the constant. We should not change the size of hole. So this is the hole. This is the hole. This is the shaft. म्हणजे काय करायचं आपल्याला होल बेसिस सिस्टम मध्ये जी काय आपला होल असणार आहे त्याची साईज आपल्याला फिक्स ठेवायची, कॉन्स्टंट ठेवायची, हलवायची नाही, चेंज करायची नाही. पण आपल्याला जे काही वेगवेगळे फिट्स आहेत, वी आर हॅव्हिंग द डिफरंट टाइप्स ऑफ द फिट्स आर देअर. क्लिअरन्स फिट, इंटरफरन्स फिट and transition fit. To achieve that fit, we have to change the size of shaft only. Okay, suppose here, for example, just example I'm going to write here. Suppose we are having one hole. Suppose we are having one hole of the diameter is the 15. Okay, of the diameter is 15, and okay, we have to follow the whole basis system. Okay, we have to follow here the whole basis system. What that whole basis system is told, that whole basis system is told us we should not vary the size of hole. We have to keep the size of hole as a constant. म्हणजे आपल्याला 50 ची साईज आता चेंज करायला का? येस, मला होल बेसिस सिस्टम फॉलो करायची आहे. होल बेसिस सिस्टम काय सांगते? होलची साईज फिक्स ठेवा, कॉन्स्टंट ठेवा, आणि शाफ्टची साईज व्हॅरी करा आणि वेगवेगळी फिट मेंटेन करा. ओके, आता मला सांगा, सपोज दिस इज द, ओके, नेक्स्ट इज सपोज वी हॅव टू अचीव द क्लिअरन्स फिट. ओके, मला या ठिकाणी क्लिअरन्स फिट अचीव करायचं. ओके, त्यानंतर मी काय करेल, तर शाफ्ट छोटं मॅन्युफॅक्चरिंग करेल का मोठं मॅन्युफॅक्चरिंग करेल? येस.
More.
Okay, here we have to manufacture the shaft. Its size is smaller. Yes. Okay, means here we have to change the size of shaft. Shaft size कमी कमी करता आली पाहिजे. 50 आहे म्हणजे it should be 40, so that we get the clearance bit. Suppose we have to achieve the interference bit, then what we have to do? We have to fix, we have to we have to keep the size of hole as a constant. To achieve the interference bit, what we should do? To achieve the interference bit, what we should do? We have to manufacture the shaft whose size is bigger. Is correct? It is correct.
Yes, sir.
Like this. Suppose it will be the 51. Okay. Then to achieve the transition bit, what we should do? Again, we have to manufacture the shaft in such way that the tolerance zone of that shaft and the tolerance zone of that size of hole, it should be equal. Okay, somewhat equal, overlapped. Like this manner, we have to manufacture the shaft and we have to achieve the transition fit. Means here from this example you can easily understood whether once we have to change the size of hole here. म्हणजे आपण इथे एकदा तरी होलची साइज चेंज केली का आता? Yes.
No.
Okay, just we have vary the sizes of, yes, just we have vary the sizes of shaft or hole. ह्याच्यामध्ये मी शाफ्टची साइज व्हॅरी केली का होलची साइज व्हॅरी केली?
Shaft.
Only we have to vary the sizes of shaft and we have kept the size of hole as a constant. This system is called as the hole basis system. Understood? Understood?
Yes, sir.
Okay. Then important point is, again very important point is, see, this is the very primary information we can call it. It is the introduction. Okay, again one more point you have to remember during this hole basis system. Okay, the important point is in that hole basis system, the in that whole basis system, say this is the point number 1 we can call, and say this is the point number 2. In that whole basis system, the lower deviation, the lower deviation of hole, the lower deviation of hole should be 0. Should be 0 means what? Should be 0 means what? Anybody? Please tell me. In that whole basis system, the lower deviation should be 0. म्हणजे काय? Yes. Lower deviation should be 0. Yes, Asmita.
Lower limit and basic size same.
Okay, good. Means what? Suppose we have to produce one hole. Example. Suppose we have produced one of the hole. Suppose this is the hole we have produced here, and just say the diameter of that hole is 15. The diameter of that hole it is 15. Okay, it is 15. But we are knowing that to produce the exact size or exact size manufacturing, it is not possible. So that suppose the size of your hole it will be exceed. If suppose your size of hole it will become 51, it will become the like this. म्हणजे आपल्याला 50 चं होल ड्रिल करायचं होतं, पण व्हेरिएशन किती झालेलं आहे? किती झालेलं आहे? Yes,
51.
51. Again in this whole basis system it is acceptable. It is acceptable. Here they have written one sentence, the lower deviation of hole should be 0. म्हणजे समजा, म्हणजे जर तुमचं होल 50 च्या ऐवजी 49.99 जर मॅन्युफॅक्चरिंग झालं, we can, it is not a whole basis system. It is not allowed. It is not allowed. म्हणजे फक्त आपण काय करू शकतो, ह्याचं अप्पर डेव्हिएशनच देऊ शकतो. होल बेसिस सिस्टम मध्ये आपण काय करू शकतो, फक्त we can give the upper deviation, we should not allow the lower deviation. बरोबर आहे का? Yes or no? Understood? म्हणजे तुमचा होल एक्झाम्पल परत एकदा समजा एक्झॅक्ट बेसिक साईज किती आहे होलची 20 mm आहे. ओके, 20 mm. जर तुमचा होल अप्पर डेव्हिएशनला तयार झाला म्हणजे 20.5 ला तयार झाला, इट इज ऍक्सेप्टेबल. म्हणजे काय ते लिमिट असेल ते, म्हणजे फॉर एक्झाम्पल 20+1 लाईक काय लिमिट असेल. ओके, 20.5 ला तयार झाला, अगेन इट इज ऍक्सेप्टेबल. म्हणजे होल बेसिस सिस्टम मध्ये अप्पर डेव्हिएशनला वाव आहे, पण तुमचा होल समजा 19.99 एवढा तयार झाला, इट इज कॉल्ड एज द होल बेसिस सिस्टम. Yes.
No.
Why it is not called a whole basis system? Because in that whole basis system your lower deviation should be 0. Lower deviation should be 0 म्हणजेच काय पाहिजे, तुमचं लोअर डेव्हिएशन म्हणजे तुमची काय पाहिजे, बेसिक साईज पाहिजे ना. बरोबर की नाही?
Yes, sir.
That point you have to. So understood? Yes or no?
Yes, sir.
Okay, so which point you have to remember in that whole basis system? In that whole basis system, the size of hole is kept constant and the size of shaft we have to vary to achieve the different fits. And the important point is in the whole basis system, your lower deviation should be 0. Lower deviation should be 0 and we can vary the upper deviation, no problem. Okay, so understood that 2 pointer? Yes.
Yes, sir.
Okay, then how to show it graphically? Just 1 minute, I will draw here one figure so that you will understand better. Suppose I'm going to draw here one shaft, sorry, one hole. Suppose this is the one hole is there. So this is the one hole and I will draw here the shaft. Suppose this is the hole. Okay, just example. Suppose this is the hole, and suppose see here. Okay, so extend here. Suppose this is the one hole is here. So this is the hole. In that hole basis system, we are kept the size of hole as the constant. For example, suppose the size of that hole, the basic size of that hole, it will be the 50. Okay, example, it will be the 50. In again, the second point is the lower deviation of hole, it should be 0. म्हणजे lower deviation असा पाहिजे का ह्या होलला? Yes, your lower deviation should be 0. पण आपण upper deviation देऊ शकतो का?
Yes, sir.
Yes, yes. म्हणजे समजा जर आपला होल 50.1235 चा काय तयार झाला, अगेन इट इज ऍक्सेप्टेबल. थोडा जर होल आपला मोठा तयार झाला तर हा होल बेसिस सिस्टम मध्ये ऍक्सेप्ट असतो. इट इज कॉल्ड एज द होल बेसिस सिस्टम. बरोबर आहे का हे? जे काय जे आपल्याला वरचा टॉलरन्स दिलेला आहे तो असं अप्पर साइडचा टॉलरन्स. ओके, म्हणजे जर तुमचा होल एवढा तयार झाला, वी कॅन कॉल इट इज द ऍक्सेप्टेबल. हे चालतंय आपल्याला होल बेसिस सिस्टम. ओके, पण मला सांगा आता, जर आपला होल बेसिस सिस्टम फॉलो करतोय आणि जर होल माझा इथं 49.9 चा तयार झाला तर इथे वी कॅन कॉल इट इज द होल बेसिस सिस्टम.
No.
No. Why? Because lower deviation should not be 0. Sorry, lower deviation should be 0. लोअर डिव्हिजन म्हणजे आपली बेसिक साईज पाहिजे, ह्याच्या खाली आलं तर आपल्याला चालत नाही. बरोबर आहे का? म्हणजे आता फॉर एक्झाम्पल आपली ही साईज किती झाली समजा, इट इज कॉल्ड एज द बेसिक साईज. हे तुमचं काय तर अप्पर डिव्हिजन. समजा अप्पर डिव्हिजन आपलं आहे 50.0102 लाईक काय वॉटेवर. ओके ओके, म्हणजे आपण आता फुलची साईज फिक्स केली का? कॉन्स्टंट ठेवायची. किती असणार आहे? जी काय 50.1 50.2 लाईक असेल ते एवढी आपण कॉन्स्टंट ठेवलेली आहे. ओके, and right now we have to achieve the different fits. ओके, आता मला सांगा डिफरंट फिट अचीव करायचे, मला पहिल्यांदा क्लिअरन्स फिट अचीव करायचंय. आता क्लिअरन्स फिटला कंडिशन कशी असणार आहे वेळानो? शाफ्ट कसा पाहिजे? आपण कसा शाफ्ट मॅन्युफॅक्चरिंग केला पाहिजे या ठिकाणी? आता
Small.
स्मॉल केला पाहिजे, म्हणजे लाईक दिस. फॉर एक्झाम्पल, सपोज दिस इज द शाफ्ट. Suppose this is the shaft. Okay, so this is the shaft, and so this is the tolerance zone for the shaft. So this is the tolerance zone for the shaft. See, shaft, this is the hole, and this is the tolerance zone for that hole. Okay, whether it is clearance fit? Yes.
Yes, sir.
म्हणजे आता ह्याच्यामध्ये काय मी चेंज केलेलं आहे? फक्त शाफ्टची साईज मी व्हॅरी केली, शाफ्ट छोटा बनवून आणला. इट्स कॉल्ड ॲज द क्लिअरन्स फिट. होलची साईज फिक्सच आहे. आता परत सेकंड कंडिशन मध्ये मला कुठलं फिट तयार करायचं? इंटरफरन्स फिट तयार करायचं. ओके, अगेन वी हॅव टू व्हॅरी द साइज ऑफ ओनली शाफ्ट, डज नॉट व्हॅरी द साइज ऑफ होल. ओके, सेकंड असणार माझं फिट इंटरफरन्स फिट मला तयार करायचं. सपोज इंटरफरन्स फिट. What is the condition for the interference fit? We are knowing that in that interference fit, your shaft should be bigger and that hole should be smaller. And already we have fixed the size of hole. See, this is the size of hole already we have fixed, so that we should not vary the size of hole. Just we have to vary the size of shaft only. Then how to draw the shaft here? Like this. Okay, so see here, this is the shaft. We have manufactured the shaft here with larger diameter. So this is the shaft, and see here, this is the tolerance zone for the shaft. This is the tolerance zone for the hole. Okay, so it is interference fit. Yes, it is interference
Yes,
fit.
sir.
See, this is the clearance fit. This is the interference fit. Again, here you can easily observe we have just varied the size of shaft only. We are not changing the size of hole. ह्याच्यामध्ये मी होलची साइज चेंज केली का? Okay, then last fit is the transition. And how to achieve the transition fit? Okay, we are knowing that how to achieve the transition fit. Yes, yes, yes. Anybody? Hmm. This is the shaft. This is the tolerance for that shaft. This is the tolerance for the, both are overlapped to each other. This is called as the transition. Again, we have to change the size of shaft only. Here also we have changed the size of shaft only. Here also we have changed the size of shaft only, but we are not changing the size of, yes, we are not changing the size of
Hole.
होल. म्हणजे होल बेसिस सिस्टम मध्ये आपण काय करायचं, होलची साईज कॉन्स्टंट करून ठेवायचे, शाफ्ट साईज व्हॅरी करायचे, आणि महत्वाचा पॉइंट काय लक्षात ठेवायचा आहे, इन दॅट होल बेसिस सिस्टम वर लोअर डेविएशन शुड बी 0. म्हणजे लोअर खालती आणायचं नाही आपल्याला इथं. जर खाली आणलं तर इट इज नॉट होल बेसिस सिस्टम. ओके, वी हॅव टू ओनली गिव्ह द अपर डेविएशन इन दॅट होल बेसिस सिस्टम. सो अंडरस्टूड? येस.
Yes, sir.
Okay, means that whole basis system we are providing only upper deviation. Okay, we are providing only the upper deviation, not providing the lower deviation. That point you have to remember. So understood? It is called as the whole basis system. Okay, understood? Yes.
Yes.
Remaining
Yes,
student,
sir.
nobody are giving the response here.
Yes, sir.
Yes, sir.
So the next point is the shaft basis system. Okay, the next is the shaft basis system. Now see here what is meant by the shaft basis system. Next is the shaft basis system. Okay, shaft basis system. Again, it is similar to that. So anybody can tell me the definition of that shaft basis system? It is just a vice versa of the whole basis system. Yes, anybody? What is meant by the shaft basis?
Size of shaft is kept constant and size of hole is varied to achieve different fit.
It is very nice. Okay, just you have to remember the definition in that shaft basis system. Okay, in this shaft basis system, the size of shaft, okay, the size of shaft is kept constant. The size of shaft, the size of shaft is kept constant, is kept as the constant, and the whole size and the whole size is varied. The whole size is varied to get the yes, to get the different bits. It is called as the shaft basis system. Means in that shaft basis system, okay, suppose this is the shaft is there, and you can call the size of that shaft is 15. Size of shaft is 15. In that shaft basis system, we have to kept the size of shaft is constant. Okay, the size of shaft we have to put as a constant, and the size of hole. Okay, the size of hole we have to vary. The size of hole we have to vary. Okay. Means for example, suppose we are having 15 mm shaft. Okay, and suppose we have to achieve the clearance speed. Okay, suppose we have to achieve the clearance speed. Okay, what is the condition for that? Means whether we have to vary the size of shaft or vary the size of hole. Here,
Size of hole.
okay, means suppose we have to achieve the clearance fit in that shaft basis system. म्हणजे shaft basis system मध्ये मला clearance fit achieve करायचा आहे. Okay, what is the clearance fit? Clearance fit is indicate the shaft size should be smaller, hole size should be bigger. Okay, this point we are knowing. बरोबर आहे. म्हणजे मला हे काय करावं लागेल आता? होल आपलं बिगरचं ड्रिल करून घ्यावं लागेल. कितीचं होल घ्यावं लागेल ड्रिल करून ह्या ठिकाणी आपल्याला? It should be 51. Okay, or it should be above the 50 so that it will provide the clearance fit. Okay, मी म्हणजे काय केले या ठिकाणी? I have changed the size of hole only. Okay, here I have changed the size of hole. Now suppose we have to carry out the interference fit. Okay, interference fit. Okay, already we have fixed the size of shaft. What is the size of shaft? It is the 50. Okay, and we have to achieve the interference fit. What is the condition for the interference fit? Yes. What is the condition for the interference fit?
Shaft size greater.
The shaft should be greater, hole should be small. Okay, म्हणजे आपल्याला इथं होल आता किती ड्रिल करून घ्यावं लागेल? In this condition, yes.
49.
Okay, somewhat 40. So that it will achieve the interference fit. Okay, and what is the condition for that transition fit? Here we are having 15 mm shaft, and again we have to manufacture the pole of somewhat 59.90 or 51 like this, so that the tolerance zone of that both are overlapped. Okay, means here you can observe here in that shaft basis system we have fixed the size of shaft. Okay, we have fixed the size of shaft and we have varied the size of, yes, we are varying size of hole only. Okay, such system is called as the shaft basis system. So understood? Yes.
Yes, sir.
So again, important point is remaining here regarding to that shaft basis system. Okay, what is the important point is remaining here? So anybody can? Which point should be there? Yes.
Upper deviation of shaft should be 0.
Upper. Yes, in that whole basis
Deviation of
system.
shaft.
Okay, in that whole basis system we are kept a, yes, lower deviation is 0. But in that shaft basis system we have to put, yes, which deviation? Which deviation?
Upper.
The upper deviation. It is important point. Huh? It is important point. The upper deviation. The upper deviation of shaft. Upper deviation of shaft should be 0. Should be 0 means suppose we are having, so this is the shaft. Okay, suppose this is the shaft is here, and suppose the size of that shaft it will be the 20. Basic size of that shaft it will be the 20. Okay, and suppose we have manufactured the shaft whose size it will be like this, 21.2. Okay, like this shaft we have manufactured. Whether it is allowable? Yes.
No.
Why it is not allowable? Okay, suppose we have manufactured the shaft of the 20 0.1 like this. Okay, for example, 0.1, 0.1. Okay, in it like this. Then tell me, in this condition, whether it is shaft basis system? Yes.
No.
Why it is no? Because in that shaft basis system, they have given one rule, that is the upper deviation of the shaft. The upper deviation of the shaft should be 0. म्हणजे आपला shaft जर असा मॅन्युफॅक्चरिंग झाला, suppose we have manufactured the shaft like this. Like this, suppose here we have manufactured the shaft like this in that shaft basis system, like 19.19. If such shaft is manufactured, then tell me, it is acceptable?
Yes.
It is acceptable? Yes.
Yes, sir.
So means here upper deviation should be 0 and lower deviation is allowable. जर तुम्ही छोटा shaft बनवत गेला थोडा, again it is acceptable and it is a shaft basis system. Okay, that point you have to remember. Okay, in that the shaft basis system, in the shaft basis system, upper deviation should be 0, and in the hole basis system, yes, in the hole basis system, yes, lower deviation should
Lower
be 0.
division.
The lower deviation should be 0. That point is important point. Okay, that point you have to remember. So once again I will repeat, in the hole basis system, the size of hole, okay, the size of hole is kept as the constant and the shaft size is varied to get the different bits. And again, the important point to that hole basis system is, in the hole basis system, the lower deviation should be 0, and in the shaft basis system, the size of shaft is kept as the constant and hole size we can vary to achieve the different fits. And the shaft basis system, the upper deviation should be 0 and lower deviation is allowed, like this. Okay, so understood? Whether you have understood the shaft basis system and hole basis system?
Yes, sir.
Okay, then can anybody guess here? So which system is feasible? Whether shaft basis system is feasible or hole basis system is feasible? Yes, generally out of that two system, hole basis system and shaft basis system. Okay, hole basis system and the shaft basis system, out of that two system, that hole basis system is generally prepared. Okay, the hole basis system is generally prepared for the mass production, because in that hole basis system we are varying the size of shaft. We are varying the size of shaft and we are kept constant the size of hole. Okay, so to vary the size of shaft, it is simple. To vary the size of shaft, the shaft आपल्याला छोटा मोठा मॅन्युफॅक्चरिंग करायचा, हे सिंपल आहे, with the help of the turning process, with the help of the turning process on the lathe machine. Okay, on the CNC machine. बरोबर आहे, किंवा with the help of the grinding process we can easily vary. Okay, we can easily vary the size of shaft. But okay, one point you have to remember, the size of hole. Okay, generally we are producing the hole with the help of the standard drill bit. Standard drill bit आपण होल कशाने ड्रिल करतो? स्टँडर्ड ड्रिल बिटने करतो. जी काय ड्रिल बिट असणार आहेत आपली, ते कशी असणार आहे? स्टँडर्ड असणार. त्यामुळे आपल्याला इजी आहे का सगळं व्हॅरी करणं? जी बिट असणार आहे ते 10 mm 5 mm काय तर अशी साईज मध्येच असणार आहे फिक्स. त्यामुळे एक्झॅक्ट व्हॅरी करणं शक्य आहे का? ओके, सो दॅट इन दॅट जनरली होल बेसिस सिस्टम इज जनरली प्रिपेअर्ड. कारण का होल बेसिस सिस्टम मध्ये आपण होलची साईज एका स्टँडर्ड ड्रिलने आपण फिक्स करू शकतो आणि शाफ्टची साईज आपण कितीही व्हॅरी करू शकतो विथ हेल्प ऑफ द टर्निंग और ग्राइंडिंग प्रोसेस. बरोबर आहे, पण शाफ्ट बेसिस सिस्टम मध्ये आपण होलची साईज व्हॅरी करू शकत नाही जास्त वेळा. इट इज डिफिकल्ट टास्क. Okay, so that generally the whole basis system is prepared more. Okay, yes. Okay, then tell me how to represent that whole basis system and shaft basis system in graphical. Yes, yes, any idea how to represent that whole basis system and shaft basis system? First up, we will prepare here the whole basis system. How to show the whole basis system in graphically? Here, shaft basis system. Yes. How to show it? How to show? Okay, so first up, I will write down here the one 0. Suppose this is the 0. Okay. Here again it is 0. Then tell me, in that whole basis system, okay, whole basis system मध्ये आपण काय पाहिलेलं आहे? Yes. whole basis system मध्ये आपण काय करायचं आहे? Yes. whole basis system मध्ये size of hole is constant. Size of hole is the constant. Okay. आता size of hole constant कशी असणार आहे? Upper deviation allowed असणार आहे, lower deviation 0 असणार. म्हणजे for example, suppose I'm going to draw here one tolerance zone for the hole. Suppose this is the tolerance zone for the hole. Suppose this is the tolerance zone for the hole. What is this? This line is indicated to 0. So this is the 0. This is the 0. Okay. This is 0 line. This is the tolerance zone for the, yes. This is the tolerance zone for the hole. So this is the upper deviation. And here the zero deviation. Okay. 0 deviation is nothing but they are the basic size. बरोबर आहे का? Yes or no?
Yes, sir.
Say this is the hole. Okay. This is the hole. Then tell me how to represent that clearance speed, transition speed here with the help of that whole basis system. म्हणजे आपण काय केलं आता whole basis system मध्ये फक्त आपण काय करतोय, अप्पर डेविएशन देऊ शकतो ना, बरोबर आहे का? अप्पर डेविएशन देऊ शकतो ना, लोअर डेविएशन आपलं 0 असणार आहे. सो दिस इज द टॉलरन्स झोन फॉर द होल. आता ह्या ठिकाणी काय असणार आहे? या ठिकाणी आपण काय ड्रॉ करू? मी आता काय आपण फिक्स करतोय होल शाफ्ट बेसिस सिस्टम मध्ये? shaft size fix करतो. समजा this is the tolerance zone for the shaft. Okay, this is the tolerance zone for the shaft. Whether it is correct? बरोबर आहे का हे? See this is the 0. 0 म्हणजे किती असेल? बेसिक साइज असेल. बरोबर आहे का? हे टॉलरन्स झोन असा बरोबर येईल का शाफ्ट बेसिस सिस्टम मध्ये?
No, sir.
कसा असेल? कसा असेल? खाली येईल. बरोबर आहे का? बरोबर आहे का नाही? रिमेनिंग स्टुडंट बरोबर आहे का? हॅलो,
Yes, sir.
का मी इथं खाली दाखवला आहे टॉलरन्स झोन शाफ्टचा? हा टॉलरन्स झोन कुणाचा आहे बाळांनो? Yes, whether it is shaft or hole.
Shaft.
का बरं शाफ्ट दाखवला या ठिकाणी?
Upper deviation should be 0.
अरे बाळा, आपण शाफ्ट बेसिस सिस्टम बघतोय. शाफ्ट बेसिस सिस्टम मध्ये आपण काय फिक्स करतोय? शाफ्ट आपण काय करतोय? फिक्स करतोय ना, बरोबर आहे का? शाफ्ट फिक्स करतोय म्हणून मी शाफ्टचं डेविएशन घेतलेलं आहे. आणि शाफ्टच्या डेविएशनला आपल्याला काय सांगितले त्याने? अप्पर डेविएशन शुड बी 0. अप्पर डेविएशन शुड बी 0 म्हणजे अप्पर डेविएशनला तुमची काय पाहिजे? बेसिक साइज पाहिजे. आणि दिस इज द लोअर डेविएशन असतं. सो दिस इज द लोअर डेविएशन. ओके, सो दिस इज द अप्पर डेविएशन. अप्पर डेविएशन आपल्याला अलाउड आहे. सो दिस इज द लोअर डेविएशन. सिंपल आहे रे. आता मला सांगा, मला क्लिअरन्स फिट करायचं आहे. जर क्लिअरन्स फिट करायचं असेल तर आपण ह्याच्यात काय व्हॅरी करतोय? शाफ्टची साईज व्हॅरी करतोय. बरोबर आहे का? म्हणजे मी शाफ्टचा टॉलरन्स झोन कुठे दाखवायला पाहिजे? आता वरती दाखवायला पाहिजे का खाली दाखवायला पाहिजे?
खाली.
या ठिकाणी येईल ना कुठेतरी. दिस इज द टॉलरन्स झोन फॉर द, यस,
Shaft.
शाफ्ट. बरोबर आहे का? आता मला सांगा इंटरफरन्स फिट दाखवायचा आहे, कुठे येईल इंटरफरन्स फिट? क्लिअरन्स. इंटरफरन्स फिट कुठे येईल? समजते का नाही? हॅलो, whether it is understood or not?
Yes, sir.
Remaining students, whether it is understood or can I repeat? Hello, hello, tell me how to show the interference bit here. Interference bit मला दाखवायचं आहे, कुठे ड्रॉ करू द्या? टॉलरन्स झोन ऑफ द
Tolerance
शाफ्ट
zone of shaft above.
कुठे करू द्या? ह्या ठिकाणी करू द्या इथं.
Yes, sir.
See, it is called as the interference bit. It is the clearance bit. आणि ट्रान्झिशन बिटला कुठे बाळा ते कुठे येईल ना मध्ये, त्याला येईल. सिंपल झालं. इट इज अ ट्रान्झिशन बिट. सिमिलर ह्या ठिकाणी कसं येईल सांगा? ह्या साईडला शाफ्ट बेसिस सिस्टम मध्ये आपण शाफ्ट फिक्स केला, आता शाफ्ट हा फिक्स केलेला आहे, टॉलरन्स झोन हा शाफ्टचा आपण फिक्स केलेला आहे. आता सांगा मला इथं क्लिअरन्स बिट मी कसं तयार करणार? कुठे येईल आता शाफ्टची साईज? सॉरी, होल होल माझा कुठे येईल? होलचा टॉलरन्स झोन कुठे येईल? येईल का?
Upper side.
इथे येईल का? इथे येईल का मला सांगा?
No, sir.
म्हणजे इथे येईल कुठे? ओके, सो दिस इज द टॉलरन्स झोन फॉर द होल. म्हणजे होल काय झाला? मोठा झाला तुमचा, शाफ्ट छोटा झाला, हे झाला तुमचा क्लिअरन्स बिट झाला. बरोबर आहे का? आता इंटरफरन्स बिट कुठे येईल? शाफ्ट आपण फिक्स केलाय, होल फक्त व्हॅरी करायचं आपल्याला या ठिकाणी. हा, हे होलच असणार ना, होलचा टॉलरन्स झोन. बरोबर आहे का?
Yes, sir.
हे कुठला झाला?
Interference.
It is the interference. How it is the interference? Tell me. कसा झाला इंटरफरन्स?
Tolerance zone of shaft is above.
रिमेनिंग स्टुडंट, बाकीचे स्टुडंटला काही समजत नाही काय? येस, रिमेनिंग धुमाळ. हॅलो, रिमेनिंग स्टुडंट्स, ठीक आहे, समजलं. Okay, so this is the interference fit, and suppose in between that here it will lies here, here or here. It is the transition fit. Okay, see, in this way we can show the pole basis system and shaft basis system in the graphical representation. Okay, so understood? At least give one of the reply.
Yes, sir.
Remaining student,
Yes,
those
sir.
are not giving reply, now I will directly put your absenteeism. No problem. Nobody are giving the reply. Why? Okay, okay. During attendance, I will do it. Now see here that pole basis system and shaft basis system, it is completed. Right now, the next point is remaining, that is the selection of the fit. How to select the fit? Okay, there is one technique is there. That technique I will explain here. Okay. Okay, the selection of the fit. the selection of it. Okay, in the exam, just I will explain here the techniques. Just I am explaining here the techniques. One trick is there, how to identify the fits. Okay, suppose in the exam they will ask the question like this. Okay, 20H7. Okay, 20H7 slash G. This is the G 6. Okay, or sometimes they will ask like this also. 20H7 dash G6, or sometimes they will ask like this. 20H7 by G6. Then identify the fit. Okay, identify the fit, whether it is tolerance fit, whether it is clearance fit, or whether it is transition fit. Identify. Then how to identify it? Okay, in this manner they will ask the question. Okay, for this here it is a simple trick is there. Okay, a technique ahe, that technique I will explain here how to identify the fits. Okay, from if they have asked the question like this, MCQ type question they will ask here like this. Okay, so here just we will explain here the meaning of that each and every term. Suppose 20H7 slash G, okay, G6. Okay, here 20 it is indicate the basic size. Okay, the 20 is nothing but our the basic size. 20 is nothing but our the basic size. Then H is nothing but the whole deviation. H is nothing but the whole deviation. H is nothing but the whole deviation. Then here 7 is nothing but the IT grade for the whole. Okay, IT grade tolerance, IT grade of tolerance for the whole. Here G is indicate the shaft deviation. G is indicate the shaft deviation. Okay, shaft deviation, and here 6 is indicate the grade of tolerance for the shaft. Okay. IT grade of tolerance for the shaft. Okay. Okay, just I will explain here the techniques how to identify the fits and what is meant by the IT grade. Okay, then what is use of that IT grade, that point we will discuss later on. Okay, just I will explain here the trick or one technique. If such type of the example is there, that time you have to understood that 20 is nothing but our basic size is here. Okay, again that H is nothing but the whole deviation, G is nothing but, or that smaller, whatever smaller letter is there, it will indicate the deviation for the shaft. Capital letter, it will indicate the deviation for the whole, and the small letters numbers are there, it will indicate the IT grade tolerance for the shaft, and it is again indicate the IT grade for the shaft. H for whole, G for shaft. Okay, so understood the meaning of that question? Yes, yes or no?
Yes, sir.
Yes, sir.
Okay, so before going to that, we should know about the what is meant by the fundamental deviation. Okay, fundamental deviation. What is meant by the fundamental deviation? Yes, already we have seen the what is meant by the deviation, upper deviation, lower deviation. Then what is meant by the fundamental deviation? Okay, I will write down the definition here. The fundamental deviation is nothing but the deviation closer to the basic size. Okay, the deviation which is closer to the, okay, closer to the basic size. Okay, the basic size. Okay, already we have explained here zero line. Suppose this is the zero line is there. Okay, here see zero line. Zero line is nothing but it is a graphical representation of the basic size. Means it will show in the exact basic size. Okay. Okay. Now see here, fan. Suppose this is the 50. Basic size is the 50. Okay. This upper side it will indicate the positive. lower side it will indicate the negative. Okay, when we are moving in upward direction, it is going on to increase. म्हणजे वरती increase होत जाणार आहे 51, 52, 53 like this ना, and it will in decreasing manner 49, 48, okay, 47 like this. Okay, suppose this is the tolerance zone. Suppose this is the tolerance zone of the shaft or photo cancer. Okay, what is this? This is indicate the lower limit na? Yes, it is the lower limit or upper limit,
Lower.
and it is the upper limit.
Lower.
Okay, it is the upper limit. Okay, if suppose the tolerance zone is like this, if suppose tolerance zone is like this, then tell me what is the lower limit, what is the upper limit, whether it is upper or lower. Yes,
Lower.
this limit is lower limit.
Upper.
See now, 50 is basic size. Then what is this? Suppose it is the 48 and it is the 47. This is the 48 and this is the 47. So it is the upper limit. Huh? It is the upper limit and it is the lower limit. Okay. In this condition, you can observe here. What is meant by the fundamental deviation? Fundamental deviation nothing but the deviation which is closer to the basic size. The deviation which is closer to the basic size. They tell me here for this tolerance zone, what is the fundamental deviation? Okay, for this tolerance zone, what is the fundamental deviation? That lower deviation is fundamental deviation. The deviation which is closer to the basic size. म्हणजे ह्या basic size ला closer कुठला आहे? Upper deviation आहे की lower deviation आहे बाळांनो?
Lower.
Then it is the fundamental deviation in this case. And in this case, what is the lower deviation? What is the fundamental deviation?
Upper.
Upper deviation is the fundamental deviation. Okay, that point just have to remember. Okay. Again, okay, for the whole basis system. Okay, suppose we are having whole basis system and shaft basis system. Suppose this is the whole size. Okay, whole size. And again, suppose this is the shaft size. Okay. Here, one point you have to remember: the whole sizes are shown by the capital letters. The whole sizes or the fundamental deviations. Okay, there are the 25 fundamental deviations are there. For the whole, 25 fundamental deviations are there, and for the shaft again there is the 25 fundamental deviations are there. Okay, म्हणजे आपण 25 प्रकारचे होल तयार करू शकतो आणि 25 प्रकारचे शाफ्ट आपण बनवू शकतो. Okay, these are the fundamental deviation. And what is the point? The whole sizes. Okay, म्हणजे whole चे fundamental deviation आपण कसल्या लेटर मध्ये दाखवू शकतो? The fundamental deviation for the whole, it will shown by the capital letter, capital alphabets, means like A, B, C, D like this. And here for the shaft, we will show the smaller letter A, B, C, D, E, F, G, H like this. Okay, that point you have to remember. Okay. Okay, so first up on, I will write here the fundamental deviation for the whole or whole sizes. Suppose this is the whole size. Okay. Then which letter we have to show the fundamental deviation for the whole? Yes. Which letter we have to use?
Capital.
Capital alphabets, means like this: A, B, C, D, E, F, G, H. Okay, this is the one set again. I. Okay, I, J, then K, L, M, N, then O, P, Q, R, S, T, U, P, W, X, Y, and Z. What is this? How many letters are there? It is the 26. Okay, 26. But due to change of the standard, okay, but due to that changes in the standardization, again that I, L, O, Q and W we have to eliminate. We have to eliminate. म्हणजे आपण कुठले कुठले एलिमिनेट करायचे त्यातले I, L, O, Q and W. Okay, that how many? 5 we have to eliminate. 5 we have to eliminate. How many are remaining? It is 21. Okay, it is 21. Okay, and instead of this 5 letter, we have to replace that by G, S. Okay, GS means I is replaced by GS and we have to add ZA, ZB and ZC. Okay, so म्हणजे आपण किती रिप्लेस केली, किती कट केली आपण या ठिकाणी, किती लेटर कट केली, किती डेव्हिएशन कट केली, 1 2 3 4 5, किती राहिले 21. परत किती ऍड करायचे आपल्याला 1 2 3 4, किती झाले टोटल. ओके, सो रिप्लेस इट. कुठलं आपल्याला रिमूव्ह करायचं आहे, रिमूव्ह यातले कुठले कुठले करायचे आहेत. हॅलो,
ILOQW.
जस्ट 1 मिनिट. आय कट करायच्या ठिकाणी कुठलं प्लेस करायचं आपल्याला, आयच्या ठिकाणी कुठलं प्लेस करायचं आहे, हा कॅपिटल JS, कॅपिटल JS. ओके, त्यानंतर कुठलं रिमूव्ह करायचं आहे,
L.
एल रिमूव्ह करून टाका. त्यानंतर ओ रिमूव्ह करायचं आहे, ओ रिमूव्ह करून टाका. त्यानंतर क्यू रिमूव्ह करायचं आहे, क्यू रिमूव्ह करून टाका. त्यानंतर डब्ल्यू रिमूव्ह करा. आणि कुठले ऍड करायचे आपल्याला समोर या ठिकाणी, यस कुठले ऍड करायचे,
ZA.
यस
ZA.
झेड कॅपिटल ए, झेड कॅपिटल ए, झेड कॅपिटल बी, झेड कॅपिटल सी. ओके, these are the fundamental deviations. ओके, तुम्हाला सांगा या ठिकाणी. ओके, सो अंडरस्टूड, समजलंय का.
Yes, sir.
In similar manner this is for the whole system. ओके, शाफ्ट साठी आपण सेम करून घ्यायचं असं. शाफ्ट साठी कसं येईल, यस शाफ्ट साठी कसं येईल बघा होतं, similar manner, just you have to write down that all the letter in smaller. Okay, just you have to write down similar fundamental deviation for the shaft also, but that letter should be smaller, it should not be capital. Okay, so I will write down here. For the shaft system, how to write down the fundamental deviation here, then A, B, C, D, E, F, S, G, H. Here small GS, then G small, K, M, okay, small m, then N, again here P, yes please help me, P, R, yes, T, yes, U, P, X, Y, Z, Z small a, Z small p, Z small c. How many are there? It is 21. Yes, again it is 21. Okay, that letter just you have to remember. Okay, that letter you have to remember. Now directly I will take the example here so that you will understand better how to identify the fits. Okay, so just take the example. Okay, suppose in the examination they have asked the question like this. Okay, identify the fits of the part. Identify the fit. They have given the example like this. Okay, just I will write down the example here. If they have given the example like this, 20 yes H7 slash G6. Okay, the meaning of that each and every term already I have. What is this 20? What is this 20?
Basic size.
Then what is that mean by the H?
Whole division.
Whole division. What is mean by 7? What is mean by the 7? I integrate for the whole, then I integrate for the chapter, and this is the chapter division. Okay, but in this stricter, okay, or in this technique, suppose we have to identify the fit. Okay, but in this technique only, I am explaining here in this technique only to identify the fit. This 20 is not required us, that 7 is not required us, that 6 is not required us. Only which parts are required us, that G capital EH slash small g, that 2 points are required. Okay, with the help of that 2 point also we can easily understood the what is the type of fits is there. Okay, so that I will write down here EH. So this is the EH and this is the G. I have write down here and this is the slash. Okay. Okay, if such condition is there, if in the left side of this slash line, if, okay, just please listen carefully. If the left side of this slash line left side ला जर capital A ते EH यामधलं कुठलं जर लेटर लाईज करत असेल, if the left side of the if the left side of this slash line, if there is any letter between A, capital A to capital H, then to identify the fit we have to go in this side. ओके, समजतंय का? स्लॅश जे काय स्लॅश लाईन आहे त्या लाईनचे जे काय लेफ्ट साइडचे लेटर जर कॅपिटल ए आणि एच यांच्यामधील कुठलं तर असेल तर आपल्याला फिट आयडेंटिफाय करण्यासाठी कुठे जावं लागतंय, या जी कडे जावं लागतं. ओके, जी कडे जावं लागतं. इफ दिस स्मॉल लेटर, ओके, the right side of this slash line, if there is small letter is there, and if this small letter is lies between small a, if this small letter is lies between small a to small eh, then we have to identify it is the clearance fit. It is the clearance fit. So understood? The types of that fit is the clearance fit. Understood or not? Yes or no?
Yes, sir.
Okay. Then I will take here second example. Then tell me how to identify. Second example. 20 H11 slash G7. Identify the fit here. Again, that 20 is not required, that 11 not required, 7 is not required. Just I have to write down the EH slash small h. Then how to identify the fit? Just tell me the procedure here. What is the technique? Yes. Yes. First of all, we have to check this letter, capital letter. If this capital letter is lies between capital A to H, आहे का? आहे, ह्याच्यामध्येच आहे ना? आहे का?
Yes, sir.
जर अशी कंडिशन असेल तर आपल्याला फिट आयडेंटिफाय करण्यासाठी कुठे जावं लागेल? इन दिस साइड. ओके, देन चेक where this small letter is lies. Again, that small letter is lies in between small a to h, so that what is the fit? What is the fit? It is the clearance fit. Okay, understood? Understood or not?
Yes, sir.
Remaining बाळांनो कोणीतरी आन्सर द्या जरा. Remaining students, then tell me. If 30, yeah, sorry. If, next example. If 30 B7 slash C6, then identify the bit here. The 30 is not required, 7 is not required, 6 is not required. So directly I will write down here B slash C. Then identify the bit here.
Clearance.
How it is clearance? Tell me. How it is clearance?
फर्स्ट कॅपिटल लेटर चेक करायचं.
Hmm.
ते कॅपिटल A to H मध्ये लाईज होत असेल तर राईट साइडला जायचं.
Hmm.
अँड ते स्मॉल लेटर जर स्मॉल A to स्मॉल H मध्ये लाईज होत असेल तर क्लिअरन्स ठीक असते.
Okay, so this is the first condition. Okay, so how to identify the clearance bit? It is clear? Yes.
Yes, sir.
Then next bit I will explain here. Okay, so next example I will write out here. Suppose next 20 capital M, 20 capital M 7 slash G6. Then tell me what is the type of fit. Yes, again 20 is not required here, 7 is not required here, 6 is not required. So directly I will write down here capital M slash G. Then tell me types of fit. Yes, just see here whether that capital M is lies between that capital A to H, whether it is lies between.
No.
Okay, if this capital letter is not lies between A to H, then it is not necessary to go to this side. Okay, once again I will repeat, if this capital letter is not lies between that capital A to EH, then it is not necessary to go in this direction. It is not necessary. Okay, so and just you have to check where it is that capital letter. That capital letter is lies between here EH to EN. EH to N. If this capital initially, if this initially capital letter is lies between small GES to the EN, then we have to identify it is the transition fit. It is the transition. If this initially capital letter is lies between P to P, sorry, P to WC, P to WC. If this initially capital letter is lies between P to WC, then we can call here it is the interference fit. It is the interference. म्हणजे जर सुरुवातीचं कॅपिटल लेटर तुमचं त्या GS to N मध्ये असेल तर इट इज द इंटरफरन्स फिट. जर हे सुरुवातीचं कॅपिटल लेटर P कॅपिटल P ते WC मध्ये असेल तर इंटरफरन्स फिट असेल. जर हे सुरुवातीचं कॅपिटल लेटर ह्या कुठल्या तरी एका जर ह्याच्यामधलं असेल तर जायची गरज आहे का आता आपल्याला? जायची गरज आहे का?
No.
Okay, then take next example. If 30 capital P7 slash G6, suppose G6, then tell me what is the type of this bit.
Interference.
Yes, why it is interference? Tell me. Why it is interference? Remaining student, please tell me how it is interference. Yes.
Capital letter lies between P to ZC.
Okay.
Therefore, it
Okay, so
indicates interference speed.
means suppose the first initial capital letter is like between these sets, and it is not necessary to go to this side, na? So that we have to check it. Okay. Yes or no? Suppose 50 x6, it is capital X6, and suppose it is the H7. Then tell me. Yes,
Interference.
Interference.
it is the interference. Okay. So understood? Both the condition have understood?
Yes,
Yes,
sir.
sir.
Yes. So
Yes,
last
sir.
bit. Last bit is remaining. So if suppose if such condition is there, next example is the 20 H7 slash small k6. Then tell me how to identify the pit. Here capital EH slash small k. Then tell me how to identify the pit here. Yes. Yes, please. Okay, now see here again that initially capital letter is lies between. Again, that initially capital letter is lies between capital A to H. It is correct? It is correct?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Then to identify the pit, we have to go in this side. Check this small letter. Where it is small letter is that lying? That small letter is lying in this condition. If that small letter is lying in this step or in this container, then it will be the transition pit. And again, similar manner, if your small letter lies between in this condition, it will be the interference pit. Then tell me what is the pit? What is this pit?
Transition.
It is the transition pit. So next example I will write down here. Suppose 30 G7 slash small p 8. And tell me what is the pit?
Interference.
Why it is interference? Tell me how. Please tell me how it is interference. Yes. Tell now. Please give the justification according to this technique.
Capital letter A to capital A to capital H मध्ये लाईट होते.
Okay.
त्यामुळं फिट आयडेंटिफाय करण्यासाठी राईट साईडला जायचं
Okay.
आणि ते स्मॉल लेटर स्मॉल पी टू स्मॉल झेड मध्ये लाईट होते.
Only the interference. Good. Correct. Okay. Then tell me, suppose 50 EH7 P6. Tell me what is the pit? EH
Interference.
P. It is the interference. Okay. So understood?
Yes, sir.
Yes, sir.
20 D7 suppose GS8. Then tell me
Transition.
it is the transition. Okay. In this manner, see this is the one simple techniques. Huh? It is the simple technique, or we can say the simple trick to how to identify the pits, because that in that examination they will ask the EMCQ question like this, and they will say identify the fits. Okay, just have to follow this technique. Okay. That technique is 90.90% is correct. Okay, so understood? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so up till now we have covered the limit, fit, tolerances, basic size, normal size, then deviation, upper deviation, lower deviation, then different types of the fits, clearance fit, interference fit, transition fit, then whole basis system, chapter basis system, and how to identify the fits with the help of this technique. That much point we have covered right now. Okay, so also from this chapter we have covered the surface roughness symbols also. Okay, so only one point is remaining, that is the GD. Okay, geometrical dimension tolerance, that much part is remaining. Okay, and that part we will cover in that next lecture. Okay, so we are having the time, so that I will take the small revision here. Okay, small revision we will take here. Now the screen is visible to all.
Yes, sir.
Yes, sir.
So directly I will take the question here. Okay. So then I will read out the question here. See, this is the question number 1. It is visible to all.
Yes, sir.
Okay. What is the question number 1? Now see, the question number 1 is the 578 plus minus 0.75 is the example of the unilateral tolerance. Now see that 78 plus minus 0.75. It is the unilateral or bilateral tolerance type.
Bilateral.
Why it is bilateral? Because we have shown the tolerance on the both the side, plus side as well as the negative side, so that it is the bilateral. Okay, so it is wrong, huh? It is incorrect. It is the bilateral. Okay, it is correct.
Yes, sir.
Okay, then can we take this example? Which of the following deliver the clearance type of the fit? And how to identify? So one by one we have to check. Okay, one by one we have to check here. First is the EH7 slash P6. Okay. Then second is the EH7 G6. Third is the EH7 R6. Fourth is the EH7 F7. Sorry, EH7 F7. Then tell me the types of fit. What is this?
Interference.
It is the
Interference fit.
interference. Correct, it is interference.
Yes, sir.
Okay, it is interference. Then it is G. It is clearance bit, na?
Clearance. Yes.
It is the clearance bit. Again, it is R, P, Q, R. It is interference, na?
Interference.
Okay,
Yes.
it is interference, and it is F, small f. It is clearance. Okay.
Yes, sir.
Okay. These are the two clearance bits are there. Okay. In this manner, we have to. Then again, here same example they have asked the transition bit. They have asked the transition. Okay, then tell me how to identify it. So first of all, I will write down here so that it will become better. First is the H8 slash P6. Then second H8 F7. Third H7 G6. And fourth is the HN6. Okay, HN6. Actually, it is not correct method to show. Okay, just we will try for 3 only. What is this bit?
Interference.
It is
Interference.
the interference. It is the clearance, no?
Clearance.
And it is the again clearance. Okay, so we have to express transition bit. Transition field is not shown here. It is transition, na? Interference. It is
Interference.
here something mistake here. Okay, maybe like this could be there. Okay, so then tell. The drawing represent the or interpret the direction of lay pattern is. Which type of the pattern is showing this figure?
Radial.
Okay, it is the radial. Okay, now then which of the following symbol is used for showing that machining is prohibited? Already we have explained here the three symbols. Okay, the first symbol is like this. Okay, first symbol it was like there. Okay, then second symbol it will be the closed like this. Okay, and the third it will be the circle in here. Okay, then first upon tell me the meaning of the three symbol. Here no restriction. No restriction here. Material should be removed. Na?
Yes,
Piece of material should be removed. And here material
should not be removed.
should not be. Then tell me what they have asked the question. Machining is prohibited. म्हणजे machining should not be there. Material should not be removed. This means which symbol? This symbol. No? It is correct. Yes.
Yes.
Yes, sir.
Then tell me. They have asked the question like this: 550 plus 0.035 minus 0.025. Okay, what that 550 is indicate here?
Basic size.
Whether it is basic size, design size, or actual size,
Basic.
it is the basic size. Okay, it is correct. Okay. Again, they have different types of the fit. Which of the following pair define the clearance fit? Can you identify it? Yes, tell me. Clearance fit कुठला असेल याच्यामधलं? H.
First and second.
First is the clearance. Again, it is the clearance. What is this? It is the
Interference.
interference, and it is the transition.
Interference.
Interference. Okay. Both are the clearance. Here, now see the 570 plus minus 0.07 is the tolerated dimension. Then the maximum allowable limit is. Maximum allowable limit is. Means they have asked here what is the upper limit. Maximum allowable limit means what is the upper limit. Means here how to calculate it. 70 plus 0.07 is equal to 70 minus 0.0. So what is the maximum limit here? Yes, 70 point. What is the answer?
0.70.
0.70. It is correct, na? Yes.
Yes, sir.
Means what this answer is correct. Okay. So, next, which of the following symbol is used for showing that machining is prohibited? Yes, already we have taken this. Tell me. Machining is
First.
prohibited. First. Then next, if the machining allowance is 2, then which of the following symbol is present correctly? Machining allowance. Which symbol is correct out of this?
Second.
Second. Why it is correct second? Okay, we are knowing that in that surface roughness symbol. See, this is the surface roughness symbol is there like this. Here surface roughness value is there, na? Roughness value.
Yes,
Here
sir.
machining allowance. Here, yes, direction of lay. Here production method, and here sampling length. Okay, so here they have shown the machining allowance here. Okay, it is wrong. Again, it is wrong. Again, it is wrong. It is correct. Okay, so understood? Yes.
Yes, sir.
The next question. Match the pairs. Match the pairs. They have in one side they have given the types of direction of play. Right? See, this is the direction of play and this is the symbol representing. Then tell me whether it is perpendicular or parallel.
Perpendicular.
Which symbol? One symbol is missing. This is radial, na? It is radial.
Yes, sir.
It is multidirectional. And it is perpendicular lines. Okay. Then next, which of the following pairs define the clearance bit? Identify the clearance bit.
Second and third.
Yes, it is not. It is clearance. Third, it is clearance. Yes, it is clearance. Okay.
E8.
Means
Yes,
suppose
sir. पुढं
like
कसं?
this. H E, you consider like this. It is clearance, no problem. You can take that section. Okay, that point also we will discuss later on, if such type of they have given. In this figure, okay, in this figure show the value 0.5 indicate. Yes, 0.5 part is,
Machining allowance.
it is indicate the machining allowance, it is indicate the surface roughness, it is along the production method, sampling length and direction. It is not taken. That point is remaining. Then tell me 18 number question, please read. The whole whose lower deviation is 0, the whole whose lower deviation is 0 is called a basic hole. Yes, it's correct or wrong? The whole is there whose lower deviation is 0. Okay, lower deviation is the 0, then it is called as the basic hole. Yes, it is correct, no? त्याला आपण बेसिक साइज म्हणतो. जर त्याचं लोअर डेविएशन 0 असेल तर ती बेसिक साइज असते. ओके, इट्स करेक्ट. The size of 25 plus minus 0.02 are the example of the bilateral. Whether it is bilateral or unilateral?
Bilateral.
It is bilateral. It is correct. Take 22 number question. The unilateral tolerance. The unilateral tolerance means the tolerance provided on the both the side of the 0 line. Okay, the tolerance provided only above the 0 line, the tolerance provided only below the 0 line, and the tolerance provided only on one side of the 0 line. Yes.
D option.
D.
Yes. Unilateral tolerance are provided on the both the side of 0 line. No, but not providing. The tolerance provided above the 0 line. Yes. No. Above पण दाखवू शकतो, below पण दाखवू शकतो. Means the tolerance provided only on only one side of the 0 line. कुठल्या तर एकाला आपण चुकीचं आहे. कुठला आन्सर बरोबर आहे?
D.
The tolerance provided only on one side of the बरोबर. Then next, question take the zero line. It is the line of zero deviation and represent the actual size. Yes.
Incorrect.
What is the correct for that? It represent the.
Basic size.
It represent the basic size. Yes. 24 question. The positive allowance called the interference bit. Negative allowance called as the clearance bit. Yes.
Incorrect.
What is the true condition for that? If. Okay, what is the condition? If shaft is smaller. If shaft is smaller and hole is the bigger. Okay. This condition is called as the positive allowance. No? Yes. बरोबर का? म्हणजे this is the clearance bit. आणि interference मध्ये vice versa. म्हणजे it is it correct. बरोबर आहे? समजले का हे concept समजले? Already that concept I have explained during the allowance. What is the positive allowance and what is the negative allowance? Okay. Yes. Then interference bit. Yes, what is the interference bit here?
Second.
This.
No.
No, it is clearance.
First and fourth.
It is clearance. Okay. Yes. What about this? Match the pair. What is this? The triangle indicate the grade symbol. Na? These are the grade symbol. These are the surface of this grade. So, anybody having any guess regarding to this? Yes. Our grade is starting from EN12, na? Yes, EN12, EN11,
Yes,
EN10, EN9, EN8, EN7, EN6, EN5, sorry, 5, then 4 and 3. Okay, 4 and 3. Then for the first, it is this way. Okay. Then we have to take 2. It having 2 triangles. Okay, again we have to take 3. It having the 3 triangles.
one triangle, sir.
Here.
Yes, sir.
1 or 2?
One.
One triangle. Only one triangle is not there, I think. You please
Yes,
check.
sir. One.
It is 1. Here 2.
Yes.
Yes. And again here
3.
6 of 5 and 4 3.
4.
And here or here 4 na?
Yes.
4 like this. Then tell me. N11. I think good. It's correct. This is N11. Then what they have given N8. It having 2. It is correct. Yes. And here
Yes,
it is 3.
N5.
N5. Okay, in this you have to remember. It is correct. Yes.
Yes, sir.
Yes, sir.
Then next question. 27. Please faster. It is correct or
Correct.
wrong?
Correct.
Correct.
It is correct. A hole whose lower deviation is 0. Again, same question. And a different lay pattern. different lay pattern shows on the production drawing are different direction of lay. No? Yes. Which letter is there?
Same.
Yeah, multi-direction. Then machining is prohibited. Then bilateral. Then 31, please tell me. 31 number question. Yes. 31 number. Yes. Like this they have gone 30 plus 0.01 and minus or what they have given here? No, it is the 0.0. They tell me what is this? It is unilateral or bilateral?
Unilateral.
Yes, it is the unilateral. I think in this way they have given na. असं दिले ना त्यांनी. ठीक आहे. असं. Yes. Take 13, 34 number question. 34. They have given the surface of symbol. The meaning of that symbol is okay. The direction of lay is in the T direction. It is wrong. बरोबर आहे का? See, the direction of lay is perpendicular. It is correct. The machining allowance is 2. It is correct. And machining allowance is the 2 microns. Machining allowance is any 1 micron. Okay, it should be in micron, I think, or mm. No problem. The 3 sentences are correct. No problem. Okay.
रफनेस व्हॅल्यू मायक्रॉन मध्ये असते ना.
Yes, but they have given machining allowance. No? Machining allowance. They have asked the machining, not a micron. Machining allowance which are surface roughness value. Machining allowance. I think no, it is in. Okay, that 2 sentences are correct. Okay. That surface roughness value in micron. Okay. Then the next is 34 number question. The allowable deviation are called as allowable deviation is called as tolerance limit fit. Yes.
लिमिट.
Allowable deviations are called as the limit. Yes, or tolerance. Deviations limit we can call. The relationship between 2 mating parts are called. Yes. What is the answer for that? Yes. The relationship between 2 mating parts.
फिट्स.
Called as. What is this? It is the bilateral character here. Tell me 38 number question. Is it 38 number question? 38. The fit 570S6 in this, the H is stand for, the H is stand for shaft basis system followed for the predestination. Yes, H is stand for the shaft or hole.
होल.
It is stand for the hole, so that it is correct. Yes. 39 number.
इनकरेक्ट.
Okay. So Now that remainings are same questions. Okay, so understood. You have got the basic idea regarding to these points. Yes. So any doubt, any
Yes.
problem?
Yes, sir.
Okay, so thank you. That only that GD geometric tolerance part is remaining. So we'll discuss in that next lecture. Okay, thank you.